All righty. Everybody excited? It's 1 degree or something out there. Now, I will say what's kind of funny, though, is I'm doing interviews this week for a position on campus, facilities director, and we actually brought a candidate, and he came out of like Fargo, North Dakota, and he was down here yesterday when I'm freezing, and he was like, wow, the weather's kind of warm down here. It's always in that perspective, because he was talking about 15 below and blizzarding. So there is a little bit of consideration there. All right, so we're going to start in on week 2. One of the things I noticed a couple of people did, and one of you in class here, and I can't remember who it was, you submitted something in, one of you submitted in a Google Doc, which is just a link to it, which didn't open. One of you submitted, I think it was in Pages, which is a Mac product. For the most case in here, the best way to submit these is actually just as a text file, and you'll see that, or you can submit it in as a Word file. I will say Word tries to fight you sometimes on the tabs and everything, and I prefer just to do everything when I can inside of just a very simple text editor. But that's just me. You are welcome to use other tools. I just have to be able to open it up. So if you're the one that sent that as a Macintosh file, somebody in here, oh, that was you. Oh. Just nod, and we'll fix that the first week. But make sure that in other classes, some people aren't always that friendly, and so make sure you just always submit them as like a Word doc file or something, so we can always get to those. All right, so we want to start out with the first thing I want to look at is going over our homework, and that's one of the reasons why I say late work not accepted, because we're going to go over it really quickly. If we've already went over it, it's not fair if you didn't get it done. Now, if you got into something horrific, you had a car wreck, you had a whatever, you managed to get Super Bowl tickets for a couple weeks from now and you wanted to give them to me, those kinds of things, we could probably make exceptions. Everybody watched the Chiefs march their way into the first Super Bowl for 50 years. I don't usually, just because it was kind of an interesting thing. So it hopefully in a couple of weeks, and what I might do in a couple of weeks, because I know a lot of people have this sports ball obsession, is we'll probably move the due date on that week also to Monday, just because people will tend to be busy on Sunday and not necessarily do everything that they should. All right, so let's talk about the homework really quickly. And so I will say I posted a very quick solution to some of them, but they're not correct. And so let's talk about why some of these aren't correct if we really expand on that. So I'm going to put this up on the screen, and I'm going to try something here on the in-class session. So if I am running Land School, let's see if this will work. So I am going to try to push out. Oh, you know what? Actually, I can't do this until I fix the rest of my networking issues. So this week they updated some switches, or last week on campus. Worked really well, except it also screwed my entire lab up. So we're working on those kinds of things in the middle of everything else. So this debug here solved the major logic issues, but what does it not do from what we've looked at in here? So I'm kind of a snarky guy, and I always like a start and a stop, so I know where they start and stop. So this solves some of the logic issues, and then I always make sure that I indent so that I see that as a block of code. There's one other thing that this doesn't have that I would prefer that they have. And that is, do we introduce any of the variables in here? No. So for me, what I would prefer, and it just makes it easier later on to look at them and know what's in your piece of code, is I know I have a numeric called mid-term grade, and I always set it equal to a value. Now, if I'm just cleaning house with it, I'll just set it equal to 0. And now all that does is, because we reuse those, they're really not a variable in the sense like when you had algebra and it was always a number. What it really does is it points to a location. And that location could already have data in it. So it's just kind of a good practice. So I know I have final grade And then I think I have one more. I think we called it average. So I declare it as a numeric. So just good housekeeping is really what that is, and getting you that idea of we have to declare them. Now, some languages we don't have to declare quite as explicitly as others. Some we do. It's just kind of a good habit, though, because now I look up at this top, and I can say, hey, here's all my variables, and I see exactly what they are. And in fact, in a lot of times, I cut and paste that variable name out of here so that I always have the same variable name. Because it's really, really easy to miss a capital letter, and it's two different variables to most systems. So, all right. So the other thing that people did, which was kind of weird, and I saw several people do it, they thought these slashes needed to be included on every line. What does the / stand for? It's a what? Comment? My ears are super stuffy, so I will apologize because whatever cold thing is going around. So it really means a comment, and our computer or our compiler or interpreter, or however you want to look at it, is going to ignore that line. It's really just for us. So I could put in one here, and I could say begin declarations. And then I could come down here and I could say begin code, mainline code maybe. And you can put in as many of those as you want. If you run into something later on, you say, I don't know how to explain what I have going on, that is a great way to show us kind of what you've got going on or what you're trying to do or explain it. So the more comments. Most importantly, when we start turning in code, there's a line up here you're going to need that's got your name in it. So when I pull these down, I can see whose item it is immediately. So that's actually the first debug, and I would look at that. So we had to do a couple of things to it. If I remember right, there were a couple of variable names that were wrong. This was dividing by 3 instead of 2. And more importantly, we had to use that order of operations to fix the fact that if we didn't have these parentheses, it would add the midterm grade plus the final grade divided by some value. And so you have to be aware about that order of operations, and it will come back and bite you a couple of times. So, second one. So here's our simple little program. And again, start, and we have a stop. And then we indent so we can show that it's all blocked. Now, other editors more sophisticated than this, we could actually highlight and indent the entire block all at once. Notepad isn't that sophisticated, but it's available to everybody or something very similar. So, the same kind of thing here. We don't have any of these variables declared, so numeric miles traveled equals 0. And another one for numeric gallons of gas used. That one's hard to type for me. All right. So now we have those. And then we have another one as we go through here. So numeric miles per gallon equals 0. So we've declared our variables. So far, anyway, I think we've got them all. So we input miles traveled. We input the number of gallons used. So here's where a couple of things happened here. And I noticed a lot of people did not catch it. I was pretty lenient on the grading. Kind of, did you attempt it? Did you do anything? You got a pretty decent grade on this first one. This one was flipped around. And so always on the left is what we are assigning to. The equals, think of it as an arrow pointing to the left. It always shoves whatever on the right of it to the left. And this was actually flipped around, and it had miles per gallon on the right side. So we always have to make sure whatever we are assigning a variable to is on the left, and the calculation is on the right. So it goes from right to shoves into the left. And so if you didn't flip that, that was a consideration in there. The other one that was wrong with this one was it was gallons of gas used divided by miles traveled. Now, even my pickup, which I think sucks down gas at an alarming rate, still gets more than 1 mile per gallon. So, and it even says our calculation is for miles per gallon, which that really says miles divided by gallon right there. And so a lot of people didn't notice that when I was going through the code. So it's miles per gallon, miles divided by the number of gallons used. Number 3, we also went through in class, but unfortunately that video didn't manage to make it to live production for a whole lot of reasons. So we're going to do the same thing. So we're going to have a start. And then I'm going to come down here and tab these out really quickly. All right, and this one had all kinds of issues. So know that we have to have some declarations, and I'm going to save some time and not show those because those are pretty easy. We know that we need to declare the variables that we're going to use. So total dollars spent, we put in how many days we spent on the trip, so we could calculate the cost per day. And I think this one we had to change from a multiplication to a division. Total dollars spent divided by days on trip gives us how much we spend every day. Weeks equals however many days divided by 7. Cost per week then was total dollars spent divided by number of weeks. So if we didn't spend an entire week, it was a decimal fraction, but it would tell us how much that would extrapolate out to an entire week. And then we output the cost per day and a cost per week for a vacation. So most of you did pretty good on those. It was the making sure you indent, not putting in the comment lines. But again, you can put comments anywhere to explain what you're doing. In fact, in most languages, I can put in comments at the end of the line. This inputs what I spent. And I'm okay with that because I can see what you're trying to do and that it's separated and you can identify. Now, because we're using the self-documented code, it's also fairly evident that it's total dollars spent. If we were using a very low-level language, so we were using something that didn't allow us to create a variable name like this, and we had to call that J, input J, that would explain what we're doing also. All right, so that's the 3 that you had to debug. So very quickly, you had a problem that said you had to input pay rate, number of hours worked, a withholding percentage, and then you had to compute what you actually got back. This problem probably made you cry a little bit and took you back to the very first paycheck you got, and you thought, hey, I'm going to make all this money, and then you got the paycheck and you cried a little, right? So input pay rate. So I really need to declare all those variables. So I should have declared pay rate, and I set it to 0, and I should have done the same for all my other variables, right? So problem 1 with my solution really quickly, but I wanted to look at the logic of it here. So we inputted pay rate, input number of hours, withholding percentage, and we computed. So let me change this just a little bit, because I wanted to explain it, but now let me try it this way. So gross pay is equal to, in other words, we assign the value of gross pay so gross pay is equal to pay rate times number of hours. Now, is there any problem with that right away? What might be a problem with that? Just hypothetically, logically speaking, what could be a problem with that? How many of you have had to work? Oh, the X is not the symbol we use, yes? Ah, okay. So, logically, so, there we go. Logically, that makes sense, except for one little thing. And it's really beyond the scope of this, but I want you to start thinking about what can happen if we do something incorrectly. So say this is your business. You have an employee that worked more than 40 hours a week. What do you legally have to do? You have to pay them overtime. And we didn't discuss that in here. So let's assume this is Walmart where nobody gets overtime, right? Do they really? No. Well, most larger businesses like Walmart try to hold their employees under 40 hours so they don't get overtime. And in fact, a lot of them will hold you to under 30 hours or whatever their minimum is to get benefits, because they don't want you to get benefits so that they would have to pay those. Right below the, yeah. So where this class is a little beyond the scope of morals of Walmart, but it really happens in a lot of businesses. They try to keep you away from the dreaded benefit package that they would have to pay. So we may have to think about that later on. Right now, we're just going to assume nobody works more than 40 hours a week. So that gives us our gross pay. And then so I will change this one again. So now it looks like what we're thinking about here. So withholding amount equals gross pay times withholding percentage. All right, so again, here's a logical question for you. If they don't input that percentage correctly, so if they put in, my withholding percentage is 25%, and they put in 2.5 instead of 0.25, is that going to calculate it wrong? So as we go through here, we're going to start building in checks and figuring out how to check your numbers and values. This first couple weeks, we just assume everybody does everything right. But is that a valid assumption? Is there always somebody out there? Nancy's going, yes, and it's usually not me. So I said it was not you. All right, so now we're going to have the variable net pay. So oops, I should have had that one up there. And I'm going to say it's equal to, or in other words, I'm going to assign this, gets shoved into net pay. And so here I'm just going to put in my minus. So that's really what I was looking for, is some variation of this idea. So we figure out a couple of items, we put it in there. I did see a couple people who must have had some programming experience prior, because they actually did try to put in some of those tests and things for overtime. It's either that or they've had some programming experience, or they're one of our overthinkers, one of the two, that's what I tend to do. But so this is kind of that mainline logic of this is how we're going to start. So I want you to start thinking about, how do we solve this problem? Because if I handed you a paycheck, you could figure this out, right? Yeah, it's not hard, but it's starting to write down as, how do we get our computer to do the same thing? So that is my take on the homework. And again, this first one is kind of the super lenient, thank you for participating, let's see what you're thinking. And so I caught a couple people and I wrote comments in some cases. And I said, here, make sure you do this. If I did not make comments and you did one of these, I apologize. I was trying to grade through as much of this as I could over the weekend. And what I've discovered is trying to solve some of our local campus issues, and then trying to do this makes it a little more exciting and fun. All right. So this week, we move on to Chapter 2. In Chapter 2, we're going to get a few more tools in our arsenal. So there is, remember the programming chapter, we have a book, so you may have to go back to week 1 and remember it. But we're going to look at a couple of things. So this week, we really get all 3 things that we can build every piece of code with. All 3 things. And we've actually introduced them to you. So we have the sequence, the selection, and a loop. And so we'll reiterate those over again. Those are our Legos that we're going to snap together for everything we do. That's all we have, are 3 different pieces we can use. So it gets a little more complicated because we have to worry about something like spaghetti code, which is really that idea that it's so unstructured and it jumps around. I am the world's worst spaghetti code writer in the world. I will tell you that. That it probably is a title. I would be in the Olympics if it were an event. So when I started writing my own code and playing around way back in the nerdy old days, I used a program called BASIC, and some of you may have heard the word BASIC before, and there used to be not Visual Basic or any of the newer stuff, and it was really neat. Every line had a number, and instead of for our loops, you could do these things called go-tos, and I could loop all around and make this mess that wouldn't naturally flow and was pretty horrible. And you'll see what I'm talking about as we start talking about that a little further. So, a structure. So, a structure is either a sequence, a selection, or a loop. Guaranteed that is on your final, and you'll need to know it as we go through here. Those are the only three things we do. We're going to do some diagramming this week, some flow charting, and so I'll show you a couple of tools and how we can look at that. So we're going to diagram, and we have some flowchart symbols. So let's make sure we understand a sequence is really every task follows another task. Well, all right. I'm going to drive to school. I turn left, I turn right, I park. That's a sequence. Doesn't matter how many number of tasks, and it's going to continue all the way to the end. So there could be one task, there could be 100. It's still a sequence. So we think of a lot of things this way, are sequences of operations. To make it a little more interesting, we have the ability to ask a question. Because it is a binary at the very bottom end, everything we do is really based on a yes or no, or a 0 or a 1. So we come down here and we have a decision, and we have a yes or no. And I know you guys have all seen these in memes on Facebook and other places. But what we're looking at is we ask a question, and it can form two options. Now, the other term you'll see this is called an if-then-else statement. And we're actually going to look at even Excel. How many of you have used Excel before in here? Everybody has? Yay. How many of you built an if-then-else statement in Excel? Oh, number of hands went down a little bit. So we can do the same structure in Excel even. And so today you're going to get a new Excel skill, and you're going to get to see some of these tasks. So let's think about this where we have a yes/no question. Is it below 10 degrees outside is our question. If we say yes, it comes over here to the right, and our sequence or our response in there might be put on additional clothes. If it's no, so in other words, it's not less than 10, go to school in a t-shirt. And I've actually seen students already still out there this morning wearing shorts. I don't know, that's a little frightening. But. So, yes, no questions. Dwight's over here going, I'm going back to the Bahamas. All right. So we had a sequence, we had a selection, and now we're going to have the last one we're going to do, but the one that causes the most of that spaghetti code that I talked about, and it's called a loop. So a loop says we're going to do something over again. And this is really the most powerful one we have. This is why a computer is better than us for a lot of things, because we can do things over and over and over again on the computer, and it doesn't get tired, it doesn't get cranky, it doesn't get whiny, doesn't need chocolate, none of those kinds of things. I don't have any chocolate to throw today, so it will do things over and over again. So there's a lot of names we have to deal with. So a lot of times they call it iteration or repetition. So if you see that, that means if I say we're going to iterate this 4 times, that means that loop is going to run 4 times. So there are different types of loops. In this particular case, what we're going to start with, and you could do everything in any piece of coding if you wanted to, we're going to call this a while loop. So sometimes it's also called a do while or a while do, or maybe who knows what else you want to call it. But it does this loop while a condition is proven true. Does that make sense? So I am going to think about this as a loop that we're going to put over, and we're going to ask the question, am I warm? That's the loop question that it's dependent on. And as it loops, if it says no, let me rephrase that. Am I still cold? Let's phrase it that way. Am I still cold? It enters this loop. If I say I'm not cold anymore, it exits the loop, right? That's the way it gets out of it. If I'm still cold, if that condition is true, it comes over here and we can execute, and in that box we might have put on another shirt. And so this might loop around 4 times. You might end up wearing 4 shirts. And you might still be cold, right? So it loops. As long as that condition exists or is true, we can make this loop happen. So 3 pieces. Sequence is the easiest. A selection starts getting a little more complicated to use, and then our loop. And our loop, we can do a lot of different pieces in there. So one of the things that you're going to see that we can do is we can stack these things together. And so when I said I always want to make the start and the stop, well, that's really part of this reason I want to identify those as separate units, because what we're going to see is our code is modular. And I can start stacking pieces together. You've probably played with Legos or something else. You built a Lego out of like 4 parts, and then you had another piece with 4 parts, and you can stick them together. That's very similar to what we're doing here. We're going to attach parts together out of those 3 structures. So, this is a piece of code that has a sequence, it's got a selection, and it's got a loop. And we just stack them one after the other. So we're able to take that code and we're able to stack it. So if I look at the pseudocode on the top right, step A, step B, that's our sequence. Our condition or selection here is an if. If condition C is true, step D, else step E. And then our loop actually says while condition is true, and then step G, and then end while. So that end while tells us when we're done with the loop. The end if tells us when we're done with the if statement. So notice that's kind of framing these. What's the other clue that things happen inside of those structures on our pseudocode? In the pseudocode itself, what's our clue that it's inside of something else? Are they at the same indent line? But notice step G in our loop is inside. That tells me it's a block of code that runs inside of that loop. So we'll work on some of these. We'll work on these. All right. The loop in the pseudocode is the while statement and the end while. So while this condition is true, we're going to do this step G here. So that step G is indented to say it's a block of code. So we could actually do, let me see if I can show you here one real quick. So if I still have Notepad, I didn't have it still open, but so if we wanted to take this very condition here, so while condition is true, notice I indent. So while it's true, I might want to add 2 numbers. I might want to output some values. I might want to predict a Super Bowl. And so notice all of those are going to run as long as that condition is true. Now I didn't actually say what the condition was in there yet, but I can make an entire block of them of things that are going to happen. It doesn't have to be just one item. And our book kind of shows that here, that it's just one item. But the reality is, I can actually put those together and have an entire list of things that happen. So we can stack them together, but we can also do this. And that's really what I just showed you in our notepad, is notice this is a while loop here. But this, what is that structure? If I have three things in a row, and it's got to do all of them, what is that? It's a sequence. Yeah, so now I've actually put a sequence inside of, and I did the same thing here. So here's my condition, and this part is a sequence. So we can actually nest those structures inside of it. So this is where it starts getting a little more complicated when we start doing things like nesting them. But let's write one, and let's just kind of look at that to make some sense of it. So while condition is true, so while temperature is less than 10 degrees. So while temperature less than 10 degrees, so when that condition is true, we're going to do a couple of things. So when the temperature is cold, what are you going to do? Wear a jacket. Pack hand warmers. Call in sick. All right. So now we put a sequence inside of there. So that will run, all those things happen only if the temperature is less than 10 degrees. Once the temperature is above 10 degrees, it hits that first line and says, nope, that's not true, and it passes down to the end of that and just escapes that loop completely. So same thing with our loop here. Here, if it ran this loop and said, okay, yep, I'm going to run, I'm going to run, I'm going to run. Once that condition is no longer true, it exits out of that loop and disappears out. It says, oh, nope, we're out. So we can nest them together, and that's what we just showed here with that list of them. But we don't just are not able to just list in a sequence. I can actually put in something else. So notice inside of here, so we have a selection, right? Some condition H. But inside of here, I have a sequence, then I have a selection or a loop, and then I have another value. So you can put all of these structures inside of each other to make it even more interesting. So if we look at this, notice how we're indented on the pseudocode in another line. Do we all see that? So that says we've got this loop inside of here. So we could go back and look at ours and put a loop in. So let's go back to my notepad here. So I'm going to stop at so I'm going to put one in right here. So I'm going to say, while cold. And so I'm going to input this here. And so I'm going to turn this into a loop. So right now, tab that in. Right now, while you are cold, you're going to go over and turn up the furnace. And you've all done this before. You go and you turn up the furnace once. Are you still cold? Yep, going to go turn it over again. And until you are warm, it's going to reiterate. And so then I need an end while to tell me that we've exited that loop. So while you're cold, you're going to turn up that furnace repeatedly until you get warm, and then you're going to exit out of that loop. So now we have a loop inside of a loop. Oh, goodness gracious. So we can get a little more complicated with those. So here we have our selection. Here we have a sequence. Here we have a loop, and then another sequence all to get out of there. Yikes. So it's a little more complicated, but it's not to the point where we're scared yet. So here we have the same kind of thing. Gets a little uglier because we had to draw it over here, but what we're really having is here we have a selection, and on this side of the selection, it comes down and we have a sequence, and then we're creating a loop, and inside of that loop is another question. So we can ask these things, and I know this looks really hard so far, but when you start using them, it really is just those three pieces, and you're putting them together like blocks. So one of the things we have to worry about is this idea of something called structure. So structures, it's not horrible. So here's a couple of the things that it has to do. It can only use these three things. We can't make up some new piece. It can only have a sequence, selection, or a loop. We can't make up our own structures. A program to be structured could have any one, all, or none of those. It has to have at least one, I suppose, because to be a program. And the simplest program could be a one sequence program. So does one thing and then stops. So notice they all have that start and stop. And here's why I harp on that a little bit. Because you can only connect these structures together at those entry or exit points, the start and the stops. So when I start hooking my code to others, it's kind of helpful that I have those start and stop points identified. And you can nest things. So it's really pretty simple. And most of our stuff is fairly well structured if we follow these rules. It's when we start doing these loops and jumps and we start trying to get very fancy that we end up with some issues. So it can only have one entrance and one exit point. If you suddenly see yourself designing a loop and it's got 3 or 4 different exit points, that's not structured. We need to go back and take a look at it. And what it does is it doesn't allow us to plug in those chunks or modules individually. So programming has changed a little bit, and part of it is due to the size of the programs. So let's think about, well, we'll pick on the Macs, because I see one in front of me. So Mac OS X gets updated on a fairly regular basis. So there is a team of programmers at Apple. It's not just one person writing that, is it? No. So it's a team, so they have to have this ability to have structured code so that you can plug in modules. And in fact, with Apple, they usually have teams limited to no more than 100 people. So there's about 100 people that work full-time on the code for the base piece of Mac OS. So are there other ones that work on things like GarageBand and other software? Yeah. So, and part of that is if we make this where it's really modular or structured, where we can plug in things, it makes our lives a little easier and lets other people do part of the work for us. So here's all 3 pieces. That's it. So what I almost will encourage you to do when we start diagramming these, if you're very hands-on and you're a tactile person, you can print this slide out, cut that out, those 3 slices out, and maybe make multiple copies, and you can arrange them and see how you can do that. This really is, each one of them has a beginning, each one of them has an end point. Single entrance, single exit. And that's the kind of the biggest key to that. So because we only have a single entrance and a single exit, our loops have one slight additional piece that doesn't seem to make a lot of sense right away. And that is something called a priming input, or priming the pump. So let's take a look at this one. And I'll show you what we mean. So this is a program that says we're going to take an original number and we're going to output a calculated number at some point. This one, we're also introducing something called a condition called end of file. And we just kind of abbreviate it. That end of file can be a lot of different things. Typically what it means on a program is that you've typed in a number or a number's been passed to it that says, I really want to stop this program. So it may be things like 999 or 0. So this program's going to take a set of values and it's going to output that number times 2. It's not particularly sophisticated. We can multiply times 2 in our head in most cases, but maybe these are very large numbers. So this one's got a problem, and I'll show you what it is right away. So let's look at this one. So we have our declarations, yay, and it says we're going to have those two numbers. Original number and calculated answer are both going to be numerics. We have an input here that says we're going to input the original number. This end of file, a lot of times we also call that sentinel value. It's a way we exit out of a loop. And so in this case, maybe we said, if the user inputs a 0, they're done running our program. So you've put in the answer 1001 or something. So it's not end of file. So it comes down here and says, calculated answer is original number times 2 shoved into the left. Then we output the calculated answer, and it loops back around to that input again. All right, so couple of problems with this. One, it's not structured. Are there multiple inputs and outputs in here? So I can get from the start, I only have this weird stop here, right? There's nowhere to feed data back out. We also have a problem with our loop. And a loop has some specific conditions when we're in structured code. And that loop says, I always in a loop, I want to come back up right to the top, my decision maker for that loop, essentially. The original program we looked at before went up to this input. Oh, okay. So, all right, I fixed that. I changed it so that it only comes back up to that original question that forms my loop. And I input a number, so I input 1001. Is that end of file? Nope, it's not the number we said would get us out of there. So it calculates 1001 times 2, shoved into calculated answer, outputs 2002, and then it loops back up to the top. Oh, wait a minute. So what is this going to do? It's never changes that value, so it's just going to keep spitting out 2002 forever. There's no way for it to actually stop. Because we don't get another value, we don't get back up to that input to ask another input, it's going to go forever, and this piece is just going to cycle. So if whatever number we put in there first, it's going to just keep outputting it over and over and over again. So we have unintentionally created something called an infinite loop. So this is the ending to a lot of Star Trek movies and other things. We've created an infinite loop. All it's going to do is spin, spin, spin over and over again. So we came up with a workaround. And this is, I know, looks a little weird because we do have the second input, but we have what we call it a priming input. So beginning looks the same. We have our declarations. We have our input, so we input the original number. We still have our end of file check. So if we don't type in 0, which would be our way out, it comes over here and calculates the value, outputs it. But the last step in this sequence, it asks for a new number. So we're actually asking for that number twice. Do you see that? So when we first started, it's going to run once off of that original input up top. And then each time it passes through that loop, it gets an input down here. So this is what a loop looks like, a while loop in structured code. It is odd that we have to ask for it twice. That does seem kind of weird. Does that seem weird to anybody, or does it make sense? So it has to do how we've defined that loop, that we always come back into the top of the loop where we're asking that question. In other words, that condition, if it's true or not. So that's what a loop looks like in structured code. So why do we worry about all of this? Why do we care? Well, we want our program to be usable by other people. So that's part of the issue, is no longer does our code stand alone. We want it to be usable, so it makes it very clear, professional. In most cases, it's the most efficient way, even though I know here we have 2 inputs, which seems less efficient. But for future maintenance, so when I go back and I look at this and I go, well, I don't understand what's going on, and I didn't put any comments, I didn't put any self-documenting code. It also allows this program to be really modular. So in other words, I can take the code I created, mix it with your code, or code I find out on the interwebs, and I can snap them together into sections. So I'm taking small Legos, building little Lego structures, and then I'm putting them on the giant Lego Millennium Falcon, that kind of thing. So that's really part of the reasons about structure. So you're going to see me harp about structure a lot in here. And it's one of the things that I struggle with when I code in some languages. If that language allows me some things like go-tos and some escapes, I'm all over it because I'm trying to cheat. So it's one of the things, just because I got into some bad habits, that we have in there. So we're going to look at this structure and logic pieces a lot. So read your book to start with. So here we have an example of unstructured. So what's unstructured about this? Why does that look different? What is odd about that? So if I look at, so it's got a sequence on the top, right? G is a sequence. And we ask a question in H, right? But look at this here where we have a question in I, where I think maybe we're making a loop, maybe we're making a structure, who knows? Does I easily come to a single exit? So it's just kind of ugly, and it makes it harder to interpret that code as we're going to work with it. All right. So make sure you read about that. We are going to start on Thursday. We are going to talk a lot more about structure, and we're going to do some looking at the homework assignments. But what I want to do is we talk about that if-then statement, and I want to show you what in Excel, what we're talking about. So if you'll open up Excel, I think everybody's got one in here. And some of you have done this, it sounds like. So Excel can do a lot of these crazy things that we want to do in a program. So we want to ask the question. So here I have a cell in Excel. How do I always start a formula in Excel? Equals always starts our formula. So I want to ask a question about another cell. And so I'm going to come over here, and I'm just going to put it in this column over here, so I got to escape. So, and I'm going to put in a grade. And I'm going to put in 84. So you got an 84 on a test. What I really want to do is construct a structure that says, what is that grade as a letter grade? Because I can do some pretty amazing things with if-then statements in Excel. So we always start with an equals, and our formula actually shows up here. So if I type if, it actually says, all right, checks whether a condition is met and returns one value if true and another if false. So it will do an if then else statement right there. So if, so my logical test, so I'm going to put if that cell, I5, is greater than 80, comma, A, comma, F. So there's only 2 grades in this particular scheme. I need to change that so that's in quote marks. So in this particular case, does it say I've got an A? No, it's got an A. But if I change that to a 79, what am I going to get? Oh, but wait a minute. I put in an 80. Shouldn't 80 give me an A? Oh. So we need to look at our logic there a little bit. And so sometimes we do the same thing when we have a computer program. We run into this kind of a logical issue. So why when it says, I put in 80, and I said if it's greater than 80, I get an A. So why is it giving me the value F? Oh, so I really need to say greater than or equal to because it could be equal to that. And those kinds of problems trip us up all the time. Now, right now that only asks a single question. It says if it's greater than 80, we get an A or they get an F. Can I actually nest these together in Excel? Could I ask the same question repeatedly? So in other words, what is our grading scale here at Peru? So it's out of 100, so it's 90% is for an A, 85 for a B plus, 80 for a B, 75 for a C plus, 70 for a C, 65 for a D plus, and anything below 60 is an F, right? So that's kind of our general grading scale. Some places are even worse. They have the minuses. So how could I write this so that it would return the correct value no matter what grade I put in there? So right now it really only says, so we'd really want to change that to 90, right? So we start at the top, 90, or can I expand that? Can I nest those structures together? So instead of returning a value if it's false, what if I put another if statement in there? Can I do that? Yeah, so if I5 greater than or equal to 85, colon B, and I'd have to nest all the way through there. So it would take a little bit to do that, right? So I'm nesting each piece, but that's essentially what we're doing. I took one very small piece of code and I'm nesting it together. Well, I'm going to test this to see if that's actually a B plus, else B. So I want to see if this works. So 85 should be a B plus, 90 should be an A, right? 89, B plus. Is that pretty slick? Now, again, I could replace that B with another if statement. So I could say then, if I5 greater than or equal to, I did 85, so now I do 80. And 80 is a B. And then I go, all right, well now I want to do the same thing. So if I5 greater than or equal to 75. So notice how we're nesting all those structures together. What we're really doing is forming a sequence of if-then statements. If I5 greater than, which one did I do, 70, C, comma, and I think C is where I'm going to call it, and everything else is an F. So, oh, I did I just delete my entire formula? Great. I did. That's handy. There we go. So now, well, I deleted it back a ways. But we can nest those together. I use some similar formulas. So when I take your grade out of Blackboard, I want to be as objective as possible. I don't want to see that, man, Dwight's over there, and I'm mad because he's in the Bahamas, and I'm in the freezing cold. Ooh, I'm not going to round that up. I write a formula like this that goes through Blackboard and very objectively says, here's what your final grade is. Here's what it actually is. And that's what I do. So Excel can do a lot of these steps that we're going to look at. Now we're going to show you some better ways to do things. And I'll actually show you an even better way with Excel. But I want you to see that we use these same kinds of things out in the world around us. All right, so for this week we have an assignment. So I want you to start thinking about it. We'll look at them in class. So we have a quiz over Chapter 2, so you will need to read that a couple of times. This week, though, you're going to have to turn in a flowchart and the pseudocode for a problem below. So there are drawing features in a lot of tools, and we can explore a couple of them really quickly. You have to a structured flowchart describing a retail store employee processing a customer purchase including 2 decisions. Or you can do it for the game Rock, Paper, Scissors, or the TV show Deal or No Deal. So we're going to start thinking about those ideas, and then on Thursday we'll explore a couple of how to start on those. So if you have questions about the homework, please email me or ask about them. Again, I have some very rudimentary examples here, and we went through on our video how to do a little better job of those. That's what our homework's going to be. There is a test. Luckily, notice there is no discussion board for this particular week. If you have not taken the time to introduce yourself on the discussion board, please do so, just so everybody kind of knows who everybody is. You're also welcome to post pictures of yourself or a link to social media if that's how you share photos. Well, let me phrase this. Appropriate social media. After a couple of years ago, we had an incident where it was horrible. Appropriate social media. How about that? If your grandma doesn't want to see the pictures, we don't need to see them. How about that? All right, guys, any questions? Yes? No? Going 3 times? I am off to go do interviews for a candidate on our campus. I will post this up at